Hey everyone, and welcome. Today, we're going to pull back the curtain on something we use every single second of our digital lives, but maybe don't think about too much: computer networking.
I mean, really think about it for a second. You click on a link, you type in a search, and bam! In less than a blink of an eye, information from a server that could be thousands of miles away just appears on your screen. How in the world does that happen?
Well, it's not magic, even though it sure feels like it, right? It's all because of this incredible, complex, and fascinating system of connections, rules, and hardware. This is what makes everything from sending a simple email to streaming a 4K movie possible, and today we are going to break it all down.
All right, so let's start at square one. Before we dive into all the cool, complicated stuff, we've got to get a handle on what a network even is, and maybe more importantly, why we even bother with them in the first place.
You know, at its heart, it's actually super simple. Networking is just connecting stuff so it can talk to other stuff. That's it. Think of it like building a little digital neighborhood for your computer, your phone, maybe even your printer, so they can all share things and chat with each other. So why connect everything? Well, the reasons are literally all around you. You want to share a file instantly? That's networking. Access the internet, which is just the biggest network of all? Yep, networking. Even just being able to print a document from your laptop to a printer down the hall, it all comes down to being efficient and connected.
Okay, so we've got the what and the why. Now let's get into the how. We're going to look at the core building blocks of any network out there, how big they are, what shape they take, and the actual physical gear that makes it all run.
You know, one of the easiest ways to think about networks is by their size. You've got your LAN, your local area network. That's super small, like the Wi-Fi network in your house. Then you scale up to a MAN, a metropolitan area network, which can cover an entire city. And then you've got the big one, the WAN, or wide area network. And the ultimate WAN? That's the internet itself, stretching across the entire globe.
Networks also have different shapes, or what we call topologies. The star is what most of us use today. See how everything connects to a central point, like your router? It's great because if one device goes down, it doesn't mess up everything else. Then there's the old-school bus topology, which is kind of like a set of Christmas lights. If the main cable breaks, the whole thing goes dark. And finally, you have mesh. This is beast mode for networks, where every single device is connected to every other device. It's crazy fast and reliable, but wow, is it expensive.
And this is the actual hardware that makes it all happen. First up, your modem. Think of it as a translator. It takes the signal coming into your house and turns it into something your computer can actually understand. Then you've got the router. This is the traffic cop of your network. It's constantly directing little packets of data, telling them exactly where to go. And finally, the switch is like a super efficient mailroom sorter, making sure the data moving inside your local network gets to the right device fast.
Okay, so we have all this hardware connected, but how do the devices actually talk? How do they make sure data doesn't just get lost in space? Well, just like us, they need two things: a shared language and a good address system. This is where protocols come into play.
Protocols are basically the rules of the road for digital communication. You can think of them as the grammar for a language. For example, HTTP, you see that at the start of every website, right? That's the protocol for web browsing. SMTP is the protocol for sending emails. Without these shared rules, it would just be complete and utter chaos online. And to make any of this work, every single device needs an address. Actually, it needs two kinds of addresses. First, you have the IP address. This is like the mailing address for your house. It tells the big, wide internet where to send stuff, and it can change if you connect to a different network. But then you have the MAC address. This is more like a unique fingerprint. It's permanently burned into the hardware itself and is used to identify your device just on its local network.
And just to add one more crucial layer, there are actually two types of IP addresses working together. Your internet service provider gives your whole home just one single public IP address. That's the address the rest of the world sees. But then your router acts like a building manager. It gives out unique, private IP addresses to every single device inside your network: your laptop, your phone, your smart TV. This keeps everything organized locally and adds a nice layer of security.
All right, we've talked about the parts, the shapes, the rules, the addresses. Now for the really cool part. Let's put it all together and follow the journey of a single web page, from the moment you click to the moment it appears on your screen.
It feels instant, doesn't it? But what's actually happening behind the scenes? There's this incredible lightning-fast chain reaction. Let's walk through it step by step. So here's what happens in the blink of an eye. Step 1.
You type a website name. Now, computers don't understand names. They speak in numbers. So, step 2, your computer asks something called the DNS. Think of it as the Internet's giant phone book to look up that name and find its real, numeric IP address. Step 3, once it has the address, your browser sends out a request. Step 4, the server gets the message, says, "Okay, I got this," and sends back all the files that make up the website. And finally, step 5, your browser catches all those files and acts like a construction worker, quickly assembling them into the complete web page that you see. All of that in less than a second. Amazing.
Okay, so with all this data zipping around the globe, there's a really important question. How do we keep it all safe? So we're going to touch on that, and then we'll finish up with a quick look at what's next for the future of networking.
Protecting our networks is absolutely critical. You've got a firewall, which is basically a digital security guard, deciding what's allowed in and what gets blocked. Then there's a VPN, which creates a private, encrypted tunnel for all your data. Super important for privacy. The encryption itself is what scrambles the data to make it unreadable. And a proxy server can help hide your real identity online. These are the shields that protect us in the digital world.
And looking ahead, man, it's not slowing down. We've got 5G and even 6G on the horizon for ridiculously fast mobile speeds. The Internet of Things is connecting everything from your smart thermostat to your car. And way out there, things like quantum networking are being developed that could one day give us communication that is literally unhackable. The future is wild.
So when you really step back and look at the whole picture, it's pretty clear, isn't it? Networking isn't just some techie topic. It's the invisible foundation of our entire modern world. It's the circulatory system of our digital society, powering pretty much everything we do.
From that little network in your home to the massive global web that connects all of us, it's all built on these same core ideas we just talked about. And now that you know the basics, what part of this incredible digital world are you going to explore next?